In this video, we're going to introduce parabolas in our conic sections unit. So a parabola is formed by taking a plane and slicing along a cone diagonally in this instance. And if we slice along the bottom cone here, the shape we obtain is a parabola. Now, we've talked about parabolas in the past when we discussed quadratic expressions, but here we're going to take a look at each of these other three types of conic sections as well in the next few videos. So we're going to start with parabola and then work our way clockwise from there. So we're going to look at the vertex, focus, and directrix of a parabola from an equation. So we got some vocab, new vocab to deal with here. In this video, we're just going to introduce the concepts, and in the next video, we'll take a look at some examples. So if we look at the graph of the quadratic function f of x equals ax squared plus bx plus c, we obtain what is known as a parabola. So in the past, we've talked about quadratic expressions, and it made what is known as the graph of a parabola. Now, in terms of conic sections, the four conic sections that we saw from the previous slide, the conic sections are all defined based on specific mathematical rules. So a parabola is a set of all points in the plane that are going to be the same distance from a focus point, which is going to be inside the parabola, as those points are from a directrix line. So here we have a focus point and a directrix line, and every point on this blue parabola is going to be the same distance from the focus point as it is to the directrix line. Now, we talked about in the past the vertex of a quadratic expression, which is, in this case, the vertex of a parabola, is either going to be the minimum point, which in this parabola it is because it's opening upwards, or vertex is a minimum, or it's a maximum point if our parabola is opening downward. The vertex itself, this distance from the vertex to the focus point, is going to be the same as the distance from this vertex to this directrix line. And then any, excuse me, any other point on this parabola, for instance, this point right here, if we measure the distance from this point to the focus point, it's going to equal the distance from this point to the directrix line. Notice again, the focus point is always inside the parabola. So the parabola is like a cup, and the focus point might be like an ice cube floating inside of the cup. So our general form of a parabola is our familiar quadratic equation, f of x equals ax squared plus bx plus c. And we have what are known as vertex forms of parabolas as well. So I want to start by focusing on this first, this column here, where our parabola is going to open up or down. And when we talked about quadratic expressions, we mentioned this vertex form. I believe we call it standard form. We mentioned this vertex form of quadratic expressions, a times x minus h in parentheses squared plus k, where our vertex is the point h and k. And we can see that in Desmos if we look at actually plotting the points h and k. Now let's change the color here. There we go. Okay. So as we adjust the value of h, it slides the graph left or right. And as we adjust the value of k, it slides the graph up or down. So just transformations of the parabola. Again, the value of a will determine not only which direction the parabola opens. So here, if a is positive, it opens up. If a is negative, it opens down. It'll also vertically stretch or vertically compress the parabola. So it might make the parabola a little more narrow, or it might make the parabola a little wider. So depending on the values of a, the value of a, we can adjust the appearance of the parabola. Our vertex is h and k. Now our focus point is going to be h and then k plus p, where p represents the distance from the vertex to the focus. So this distance from the focus to the vertex is the value of p in this expression, k plus p. So again, remember that the focus is always inside the parabola. So in this case, our focus point would be somewhere maybe in here. If a was negative and opening downward, focus point would be somewhere below the vertex. So it depends on which way the parabola is opening, up versus down. And the value of P is determined by looking at your value of A, and then whatever the value of A is, set it equal to 1 over 4 times P, and then solve that equation, and you'll get your value of P. So for instance, with this parabola, we have 1 for A. So if we do 1 over 4 times P equal to 1, we're going to get P equals 1/4. So if I label the points H and then K plus 1/4, I have to zoom in here a little bit. But this distance here from this blue point to this black point is the value of P. And as we adjust the value of P, it'll also make our parabola narrow or wider. So I'm just going to set P equal to 1/4. I'm going to code that in there. And then we can make that. And well, let's make this a slider. Okay, so it's not letting me do that. But in any event, we have this distance here between these 2 points is our value of P. Now our directrix line is going to go, instead of going up above for the parabola inside, the directrix line is always outside the parabola. So for this one, our directrix line is going to be y equals k minus p. So y equals k minus p, k minus 1/4 is our equation for our directrix line. And the distance between this point and this directrix line is going to be the same as the distance from this point to this focus point, this vertex to this focus point. So this is a length of p. This is also a length of p. Important to note, your focus point is always inside your parabola. Your directrix line is always outside of your parabola. Your parabola will never intersect your directrix line. Will never intersect it. All right, now for opening left and right, we switch our x's and y's and also our h's and k's. So x equals a times y minus k in parentheses squared plus h. So we can see that one with this parabola right here. So here we have opening to the right when a is positive, and if a is negative, it's going to open to the left. Let me just get rid of that. In terms of k, I'm just going to slide it up or down for this one. Again, k is associated with y's, goes up and down, and h is still going to move the graph left or right. So now we just have the graph opening left or right versus up or down. So our vertex is still h and k, but notice our h's and k's are switched. And then now our focus point is going to be h plus p and k. And again, a is still 1 over 4 times p. So now if we look at our focus point as h plus p and then k, let me reset this to 1 again. And there we go. So now this distance from this focus point to this vertex, that's our value of p. And our directrix line is going to be a vertical line, which is x equals h minus p. So x equals h minus p. So let's just see that one as well. And again, notice our parabola does not intersect the directrix line. The distance from our directrix line to our focus point is going to be the same as our distance from our directrix line to our vertex is the same as the distance from our vertex to our focus point. So this is a length of p, and this is also a length of p. All right, so that about does it for this video. In the next one, we're going to take a look at some examples of parabolas that open up and down and parabolas that open left and right. So I'll